Aloha, my name is Chong Ho Alex Yu, and I am a professor of data science and artificial intelligence. In this presentation, I will discuss the US-China bifurcation in cloud computing, causes and consequences. Today, the technological realm is experiencing a profound fragmentation, often described as tech balkanization or technological bifurcation. This term refers to the division of global technology ecosystems into separate, often competing spheres of influence. The most visible arenas include artificial intelligence, semiconductors, and cloud computing, each of which forms the backbone of modern digital economies. While AI garners the most headlines and semiconductors occupy the center of geopolitical debates, cloud computing deserves equal attention. It is the substrate on which AI is trained and deployed, the platform for global commerce, the foundation for cybersecurity operations, and the infrastructure underpinning scientific research. In the present context, a clear division has emerged. The United States and its allies largely rely on the three dominant tech giants: Amazon Web Services, AWS, Google Cloud Platform, and Microsoft Azure. Meanwhile, China and its strategic partners have consolidated around Alibaba Cloud, Tencent Cloud, and Huawei Cloud. These providers are more than commercial entities. They embody political, legal, and economic systems that increasingly diverge. To understand the scale of this bifurcation, it is important to consider the numbers. As of the second quarter of 2025, Amazon Web Services holds about 30% of the global cloud infrastructure services market, Microsoft Azure about 20%, and Google Cloud about 13%. Together, these three companies capture roughly 63 to 65% of the global market, cementing the dominance of US-based providers worldwide. In contrast, China's domestic cloud market is led by national champions. In the first quarter of 2025, Alibaba Cloud accounted for about 33% of mainland China's cloud infrastructure services market, Huawei Cloud about 18%, and Tencent Cloud around 10%. On the global stage, Alibaba Cloud maintains a more modest share of about 4%, while Huawei and Tencent each account for roughly 2% of global infrastructure services. Although smaller internationally, Chinese providers are expanding strategically. Alibaba has launched data centers in Mexico and Thailand. They announced plans to invest more than $52 billion over the next 3 years into cloud and AI infrastructure. Tencent and Huawei, while less visible globally, continue to reinforce China's digital ecosystem and project influence abroad through partnerships in regions such as the Middle East and Southeast Asia. This video will explore how the bifurcation of cloud computing came to be, why it is different from historical precedents, and what its consequences are for innovation, economics, governance, and global cooperation. A historical precedent: the Cold War divide. The current balkanization of cloud computing is not entirely unprecedented. During the Cold War, the world was divided into two opposing blocs led by the United States and the Soviet Union. Each bloc developed its own technology standards, industrial supply chains, and scientific institutions. Interestingly, the Soviet Union initially pursued its own computer designs, but by the late 1960s, a strategic decision was made to clone Western systems, most notably the IBM System 360, to keep pace with global technological advancements. This led to the creation of the SEBM, Unified System of Electronic Computing Machines, series, also known as RIAD. In this sense, there wasn't much bifurcation in computing during the Cold War. In telecommunications, the West embraced standards like TCP/IP, which later became the backbone of the Internet, while Eastern Bloc countries pursued their own protocols. Nonetheless, Russia and East Europe adopted TCP/IP after the collapse of the USSR. Yet despite these divergent paths, the impact of bifurcation during the Cold War was minimal compared to today. One key reason is that there was little trade between the two blocs, especially in high technology. The United States and its allies imposed strict export controls through the Coordinating Committee for Multilateral Export Controls, COCOM, effectively isolating the Soviet Union from Western innovations. Conversely, the Soviet Union and its allies pursued technological self-reliance with limited interaction with Western markets. Because there was little economic interdependence, the duplication of technology infrastructures remained a localized issue with few global spillovers. Why today's bifurcation is different. The situation is very different today. Unlike the Cold War era, the United States and China are deeply enmeshed in global trade and technology supply chains. Bilateral trade between the two countries still exceeds hundreds of billions of dollars annually, and the production of most advanced technologies, from smartphones to electric vehicles, depends on joint contributions across borders. U.S. firms design chips that are fabricated in Taiwan, packaged in China, and then embedded in devices sold worldwide. Chinese companies rely on U.S. software, tools, and intellectual property even as they strive for self-sufficiency. This interdependence magnifies the consequences of bifurcation. Cloud computing, in particular, is not merely a back-end service. It is the foundation for artificial intelligence, digital trade, cybersecurity, and data governance. Splitting it into competing ecosystems creates inefficiencies, raises costs, slows innovation, and undermines trust. The following sections examine the major consequences of cloud balkanization. Loss of global interoperability and economic inefficiency. Many software companies form deep partnerships with hyperscalers, and these alliances shape customer adoption. For example, SaaS Via, a leading analytics platform, has adopted Microsoft Azure as its primary hosting environment. This means that organizations using SaaS in the United States often find themselves indirectly locked into Azure's cloud ecosystem. Even though some data companies such as Oracle have its own cloud infrastructure, similar partnerships exist for major software vendors such as SAP, Oracle, Salesforce, Snowflake, and Databricks, which align their offerings with AWS, Azure, or Google Cloud. In China, a parallel dynamic is unfolding. Domestic enterprise software firms and AI providers such as Kingsoft, SenseTime, and Baidu Ernie are tightly integrated with Alibaba Cloud or Huawei Cloud. As a result, one of the most immediate consequences of bifurcation is the loss of global interoperability. At a technical level, cloud providers offer overlapping services such as virtual machines, object storage, serverless functions, and AI model hosting. Yet the interfaces, APIs, and compliance frameworks differ significantly between AWS and Alibaba Cloud. Applications built in one environment cannot be seamlessly migrated to the other. For multinational corporations, this creates a dual burden. A U.S. firm operating in China must often migrate its workloads to a local provider such as Alibaba or Huawei to comply with Chinese data laws. Meanwhile, Chinese firms expanding abroad must adapt their systems to AWS or Azure. This duplicated infrastructure imposes higher costs, creates integration challenges, and discourages smaller firms from global expansion. The result is a fractured global digital economy, where interoperability, once a hallmark of the Internet, becomes increasingly elusive. Large corporations can absorb these costs, but small and medium enterprises are disproportionately burdened. Many may be effectively excluded from international expansion because they cannot afford the compliance and infrastructure requirements of both blocs. The result is a two-tier global economy, where only the largest firms can operate across both ecosystems while smaller innovators are trapped within regional boundaries. This economic inefficiency raises costs for businesses and ultimately for consumers, reducing the overall benefits of digital globalization. Data sovereignty and regulatory friction. Another major consequence is the rise of data sovereignty regimes that reinforce the bifurcation. In the West, the European Union enforces strict data privacy protections through the General Data Protection Regulation, GDPR, while the United States has enacted the Clarifying Lawful Overseas Use of Data Act, CLOUD, which compels service providers to hand over data even if stored abroad. In China, the cybersecurity law and related regulations require that sensitive or personal data generated in China be stored within Chinese borders. This has created what some call a splinternet, where different countries have their own separate data ecosystems with their own rules. These conflicting requirements create regulatory friction for global companies. They cannot run unified global databases because the laws demand data localization. Instead, firms must fragment data storage across multiple jurisdictions, complicating data governance, analytics, and compliance. Data sovereignty, once a niche concern, is becoming the primary axis of cloud balkanization, locking companies into region-specific ecosystems. Security and trust fragmentation. Cloud computing also sits at the center of national security debates. In the United States and Europe, there is deep suspicion that Chinese cloud providers such as Huawei or Alibaba could serve as conduits for espionage or cyberattacks. The issue becomes even more complicated, especially when China laws allow government access to corporate data. In China, US-based providers such as AWS are also seen as potential vectors for surveillance or even remote control. This trust gap fuels policies that ban or restrict foreign providers from operating in sensitive sectors. For instance, many governments prohibit foreign clouds from handling defense or healthcare data. The result is further entrenchment of separate spheres of influence. Cybersecurity risks also grow as security standards diverge. If one ecosystem adopts protocols incompatible with another, cross-border operations become harder to secure. This fragmentation of trust undermines the very promise of the cloud as a universally accessible, reliable infrastructure. Innovation slowdown and duplication. Another consequence is slowed innovation due to the lack of cross-pollination and duplication. In 2018, Amazon Web Services established a research lab in Shanghai, China, but it was shut down in 2025. The primary reason cited is the escalating friction between the United States and China over technology. A senior scientist at the lab, Wang Minjie, confirmed in a social media post that the team was being dissolved due to strategic adjustments amid US-China tensions. Cloud computing is not static. It constantly evolves with new services such as machine learning platforms, edge computing, and quantum computing integration. When two blocks pursue parallel research and development tracks without sharing knowledge, resources are wasted on duplication rather than breakthrough innovation. Geopolitical and strategic consequences. The bifurcation of cloud computing also carries geopolitical implications. As with 5G, countries are pressured to align with one bloc or the other. Nations participating in China's Belt and Road Initiative increasingly adopt Alibaba or Huawei Cloud. On the other hand, NATO members and close US allies rely on AWS, Azure, or Google Cloud. This creates digital spheres of influence that map onto geopolitical alliances. In times of crisis, cloud services themselves could become weapons of coercion, with access cut off to adversaries. Already, AWS suspended services to Russian customers after the invasion of Ukraine. A similar scenario could unfold with China-linked providers. Fragmented standards, meanwhile, hinder international cooperation on issues like cybersecurity, disaster recovery, and global financial stability. Cloud computing becomes not only an economic tool but also a strategic instrument of power projection. Impact on research and academia. Finally, the split has serious implications for research and academia. Cloud platforms host enormous datasets and provide scalable computing power essential for modern science. In the West, researchers rely on access to AI APIs, supercomputing clusters, and collaborative platforms hosted on AWS or Azure. In China, academics and startups depend on domestic clouds and locally trained AI models. The divergence means that cross-border research collaboration is curtailed. Shared databases for climate science, genomics, or medical research cannot be easily synchronized. Access to advanced AI models becomes region-specific, undermining the global exchange of knowledge. The net effect is a slower pace of scientific discovery, with duplication of effort and lost opportunities for cooperation. Furthermore, some international students, for example, students from China who come to the United States to study technology subjects such as cloud computing, may discover that the practical skills they acquire are not directly applicable once they return home, even though the underlying concepts remain transferable. For academic program directors who design curricula for overseas programs, this divergence means having to prepare two separate versions of the same course to meet different technological environments. The need to duplicate efforts in this way places a considerable burden on faculty and institutions. Conclusion. The bifurcation of cloud computing is more than a technical inconvenience. It represents a profound fracturing of the digital world. Unlike the Cold War, where parallel systems existed in isolation, today's bifurcation unfolds in a deeply interdependent global economy. The consequences are wide-ranging: loss of interoperability, data sovereignty conflicts, fragmented trust, slowed innovation, higher economic costs, geopolitical rivalries, hindered research collaboration, and non-transferable skills. Cloud computing matters because it is the foundation of artificial intelligence, digital trade, cybersecurity, and data governance. Splitting it into incompatible blocks undermines efficiency, erodes trust, and slows progress. To be fair, both sides have legitimate national security concerns, and it is likely that this trend will carry on. If the bifurcation between the United States and China is unlikely to be reversed, why does examining it matter? The answer lies in clarity, preparation, and adaptation. Understanding the causes and consequences of this divide equips policymakers, businesses, and researchers to make informed choices in an uncertain landscape. Companies can anticipate higher costs and compliance burdens, universities can prepare for fragmented research collaborations, and governments can distinguish between areas where limited cooperation remains possible and areas where strategic competition will dominate. The bifurcation of cloud computing is not a problem to be solved overnight, but a condition to be managed with foresight. Recognizing its significance helps society prepare for the challenges ahead and navigate a world where technology is not only a tool of progress but also a marker of power and division. This issue is complex and often controversial, so it is natural that people will hold different perspectives. I would love to hear your thoughts. Please share your comments below. If you found this video informative, consider liking, sharing, and subscribing so that more people can join the conversation. Thank you for watching. Mahalo.